All right, so happy Wednesday. We're going to talk about Chapter 4, page 100 and 101 of the textbook, and it's trying to size for the maximum size of course aggregate. And this is an ACI recommendation. So the first one will be a non-reinforced member, and that's going to be 1/5 of the minimum dimension of the size. So what that looks like would be right here. If you have a foundation wall and then a continuous footing, you would do 1/5 this width. So 1/5 of 15 inches would be 3 inch. So that would be the maximum size of the aggregate that you would want in that mix, because aggregate comes in different blends. When we were in the lab, the newest aggregate I got was the smaller, really small aggregate. And the one that we were practice testing with had aggregate that was up to 1 inch and 1.5 inches. So depending on what we're using aggregate for would be depending on the size that we need. All right, so that's an easy one. Okay, so the next one would be a concrete slab. And it's pretty easy. It's 1/3 the depth of the non-reinforced slab. Non-reinforced meaning there's no rebar in there. So let's look at a picture of that. So right here's a picture of a slab. So if this is our rinky-dink house right here, this greenhouse, and we're wanting to do a new house, you would look at the depth of the concrete slab. So like if this was a 12-inch slab, it would be 1/3 of 12 inches. So your aggregate could be 4 inches. And then this example, it was a 6-inch slab. So 1/3 of 6 inches is 2 inches. So you would put that the maximum aggregate size for that would be 6 inches. All right, and then now to the last one. This is the more complicated one. It's a reinforced member. And so typically we want to add up all the clear space, meaning the area in between all the clear spacing, to figure out what's in here and what's the maximum aggregate size that can go in here. So here is an example of that. So when you're looking at it, this has got a lot of rebar in it, and then the little metal that's holding the rebar together, that's what they call stirrups. And that plays a part in the clear span. And then also that kind of lets you know there's your rebar and there's what you call the stirrups. And now rebars come in different sizes, so we need to look at sizing. So here's a size chart. The ones you're going to see in the homework are going to be maybe a 4-inch. And a 4-inch, and the 4-inch is the type of rebar. It's like a bar size. So if you went to Lowe's, you would see like a number 4 rebar. That would be 0.5, which is a 1/2 inch. If it's a number 5 rebar, that would be and how to convert this over to inches is if I put 0.625 in my calculator and hit math and hit fraction, it converts it over. So this number 5 rebar, which is 0.625, I put 0.625 in, hit fraction or math and fraction, it gives me 5/8. So the problems that we're going to have, you're going to look at what you're going to take the overall dimension. Your stirrups are on both problems are going to be a thickness of 1/4. So you have 2 on each side, one here and one on the other side. So you're always going to use 1/2 inch in the problems. The 2 outside covers, this is in between the stirrup and your form. All the problems you're going to have are going to be 1.5 inch cover as well. And then right here, this is 4 3/4 inch bars. What that means is there's the 3 rebars or 4 rebars on the bottom. You're always going to look at the bottom one because that's got the least amount of space. So they're number 6 rebars, which are number 6 here. 0.75 is 3/4. So you've got